Okay, now next one is probability mass function. So when we have x as a discrete random variable with the values x1, x2 up to xn with their corresponding probabilities f of x1, f of x2 and f of xn. So for x1 the probability is f of x1, for x2 the probability is f of x2, for xn the probability is f of xn. So then the set of ordered pair, that means x comma f of x, is called the probability function or the probability mass function. So probability function or probability mass function is only defined for a discrete random variable. So symbolically we can write f of xi equals to probability of x equals to xi when x equals to xi, that means I equals to 1, 2, 3 up to n, otherwise 0. That means when x is not between 1 to n, then the value for the function or the probability is 0. So if we consider one example, then it will be more clear. So let x be a random variable with the following probability function. So x equals to minus 2 with the probability 1 by 10, x equals to 0 with the probability 2 by 10, x equals to 4 with the probability 4 by 10, x equals to 11 with the probability 3 by 10. So then this is called probability mass function or PMF. Then next one is probability density function. So what is probability density function? When x is a continuous random variable, then f of x is called the probability density function of the continuous random variable x if it follows the following three conditions. Number one is all the values of the probability must be greater than or equals to 0. Second one is summation of total function is 1, and third one is we can calculate the probability value for any specific limiting form. That means, for example, probability of a less than or equals to x less than or equals to b means integration of a to b f of x dx. So for any continuous random variable, if the functional form f of x satisfies these three conditions, then this is called probability density function or PDF. So here we put one example. Say the pressure measured in pounds per centimeter squares at a certain valve is a random variable x, which probability distribution function is f of x equals to 2 over 9 3x minus x square when x lies between 0 to 3. So other than the probability value is 0. That means if x equals to 4, the probability value is 0. If x equals to 5, the probability value is 0. So this is the example for probability density function. So these are the few questions for you for your short quiz. So take 1 minute and try to assign the random variable for all these examples. Say for first one, the return on an investment in a 1 year period. So is that a discrete random variable or continuous random variable? So try to think, recall about the discrete random variable and the continuous random variable. Try to write down the answer for all these 5. I am giving you 1 minute. Okay, So for first one, the return on an investment in a 1 year period. So this is continuous and numberable because return on an investment. So return, it can be any values, any fractional values. So that's why this is continuous and numberable. The price of an equity. So the price. So price can be any value, any fractional value. So this is continuous random variable. The number of customers entering a store. So number of customers, it cannot be any fractional values. So that means this is discrete random variable. The next one, the sales volume of a store on a particular day. So sales volume, that is continuous random variable because sales volume can be any fractional values as well as integer values. And the last one is the turnover rate at your organization next year. So turnover rate, this is also continuous random variable because turnover rate can be any fractional or integer values. So I repeat, this is continuous random variable, this is continuous random variable, the third one is discrete random variable, the fourth one is continuous random variable, and the fifth one is continuous random variable. So I hope now you can be able to identify the variables and the random variables, which one is discrete random variable and which one is continuous random variable. So this is all about our today's lecture. Thank you.